Hello, my name is Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions from the section on integration by substitution. So in question 2 we're asked to calculate some indefinite integrals. So the first one is e to the t over 1 plus e to the t. The key here is to recognise that this is 1 over 1 plus e to the t multiplied by an e to the t. 1 over a function integrates to a logarithm, and the key here is that the inside of that function, 1 plus e to the t, differentiates to e to the t, which is sitting here. So this is going to be a reverse chain rule, okay, because the derivative of the inside of this is just sitting here, and so 1 over this is going to integrate to the logarithm of the denominator. Okay, so this will just integrate to ln of the absolute value of 1 plus e to the t, but e to the t is always positive, so I don't need the absolute value there. Let's just check our answer. I just might write it down here. So let's check. If this anti-differentiates to this, then the derivative of log of 1 plus e to the t plus c should be e to the t on 1 plus e to the t. And we can see how this is going to work. The logarithm of 1 on 1 plus e to the t differentiates to 1 over 1 plus e to the t. The chain rule says in addition multiply by the e to the t. The constants differentiate to 0. So you can see when you use the chain rule, you multiply by the inside function differentiated. So if you want to reverse a chain rule, you need that inside function differentiated sitting there to be able to reverse the chain rule here, right? Note, if you wanted to more formally do it, you could use substitution and let u equal 1 plus e to the t. So just note the substitution u equals 1 plus e to the t would give the simplified integral of 1 on u du, because this would be 1 on u and this e to the t dt would be the du in the substitution. So you could have done this substitution and that would be equivalent, or you could do it by inspection, just like that. In question 2d, we're asked to find the indefinite integral of cos of log of x, all divided by x. I'm just going to rewrite this integral as cos of ln x multiplied by a 1 on x dx. So the key here is that we have cos of log of x, so this is a composite function, but the inside of that function differentiates to 1 on x, which is sitting here. So we can use a reverse chain rule here. If the inside function differentiated is there, the f dash is there, then I just need to integrate cos of something. And I know cos integrates to sine. So this is going to integrate to sine of ln x plus a c. Let's check that. If we think this is an antiderivative of this, then when we differentiate our answer, when we differentiate sine of ln x, we should get the question. Now sine of stuff differentiates to cos of stuff, but the chain rule says in addition we would need to multiply by that inside differentiated. See, the constant differentiates to nothing. So we can see when we use a chain rule to differentiate, we multiply by the inside differentiated. So if we want to use a reverse set chain rule, that inside differentiated needs to be sitting there for us to be able to reverse the chain rule here. Now alternatively, we could have used a substitution. So the substitution u equals ln x would give the simplified integral of cos of u du. So we can see that this would be cos of u, and the 1 on x dx would be replaced by a du with that substitution. So you could more formally do it using a substitution u equals log x there as well. Question 2g here is asking us to find an indefinite integral of e to the r on e to the 2r plus 1. This is a bit of a tricky one to identify. The way I want to rewrite it is I want to rewrite it as 1 over e to the r squared plus 1 multiplied by an e to the r dr. So the key is that this is 1 over something squared plus 1. I know 1 over something squared plus 1 is going to anti-differentiate to inverse tan. So this looks like an inverse tan, and the key is that the inside of this, e to the r, differentiates to something that's sitting here already. So we can use a reverse chain rule, or we can use the substitution u equals e to the r, and then this would become 1 on u squared plus 1, and this would become the du. So we need to recognize that we can rewrite it in this form. Once it's written in this form, we can see we can use the reverse chain rule. This is the derivative sitting here, and 1 on something squared plus 1 anti-differentiates to inverse tan of e to the r, or 1 on 1 inverse tan of e to the r on 1 there, plus a c. Let's just check that we did that correctly. Let's differentiate our answer. If I differentiate inverse tan, that's an r there, ddr, inverse tan of e to the r, plus a c. Well, inverse tan differentiates to 1 on 1 plus that squared, and the chain rule says in addition you need to multiply by the derivative. E to the r differentiates to e to the r, constants differentiate to 0. So we can see that this does indeed give us e to the r on 1 plus e to the 2r, which is the question, the integral that we were asked to give. Okay, so alternatively, if you wanted to do a substitution, so the substitution u equals substitution u equals e to the r would give the simplified integral of 1 on u squared plus 1 du. So at this step, 1 on u squared plus 1, and this e to the r dr would become the du in that particular substitution. So by inspection, we're going straight to our answer. By substitution, you would go via this integral 1 on u squared plus 1 du there.